Lesson 3.1, Complex Numbers. Imaginary numbers are complex numbers. Imaginary number is I, or called the imaginary unit, which is the square root of -1. Now, before you've learned that you can't take square roots of -1, but you can. You just have to introduce I to do it. Now, it's a terrible name. It's not imaginary. It follows all the rules of math. It's just the square root of -1. And I squared is -1. These are the two things you really have to remember. They are useful in things like the classic examples in electricity. You have to use the imaginary numbers to do find something called impedance. It's also used in art and some other applications. Complex number is a plus bi, where a is the real part and bi is the imaginary part. So complex numbers combine real numbers, which are the ones that you usually deal with. Again, it's a terrible name. And imaginary numbers, terrible name, into complex numbers. So complex numbers are both of those. If your number has I in it, we call it imaginary. Let's simplify some square roots. Square root of -9. Well, we could divide this into 9 times -1. Square root of 9 is 3. Square root of -1 is I. Let's try square root of -12. Well, 12 could be 4 times 3. 4 is the perfect square. And we have the negative, so we have square root of -1. Square root of 4 is 2. Square root of 3. And square root of -1 is I. We can add and subtract complex numbers. It's not difficult. If you can add, say, these binomials with variables, where you just combine like terms, so you have x and 2x makes 3x. 4 and a -3 make a 1. Just combine like terms. So we have the constants, the -1 and 3 makes 2. And then we have the i's. 2i plus 3i would make 5i. Let's try another. This time we're subtracting, so 2 minus 3 is -1. -3i minus a negative. Minus a negative is like plus, so -3 plus 7 is 4i. Try one more. Usually you put the numbers first and the i's at the end, so we have a -3 plus 2. It's -1. And then for the i's, I have 2i minus I is 1i plus -3i would be -2i. How about multiplying complex numbers? Well, it's the same as multiplying binomials with x's. You FOIL. The difference is whenever you get this I squared, change it to -1. All right, so we have -I times 3, so that'd be -3i if we distribute, and -I squared. But I squared is -1, so I'll replace it with a -1. And then minus a negative is a plus, so I have 1 minus 3i. So we usually write it with the real number first and the I part second. Let's try a couple more. 2 times -6. 2 times -2i. 3i times -6, and then 3i times -2 would be -6i squared. Well, I can combine the i's, so that would be negative 22i, and I squared is negative 1. So that would become plus 6. Well, and combine that with a negative 12, so it would be negative 6 minus 22i. Let's try the last one. Would you pause it and try it? Pause the video, try the last one. Alright, here we are. And first, we have 1 times 1. Outers, 1 times negative 2i. Inners, 2i times 1. And last is 2i times negative 2i, which is negative 4i squared. Those will cancel out, and the I squared becomes negative 1. So this is 1 plus 4, which is 5. Wow, look at that. We multiplied and the i's disappeared. All right, that last example, the answer was just real. It was just a 5. Those were complex conjugates, which are the same numbers, just opposite sign on the imaginary part. When you multiply complex conjugates, the product is real. So 1 plus 2i, 1 minus 2i. Notice the 1 and the 2i are the same. The only difference is the sign in the middle. Those are complex conjugates. So to divide complex numbers, you can't have an I in the denominator. No i's allowed in the denominator. It's like a radical. You can't have a radical in the denominator. So what we'll do is we'll multiply the numerator and denominator by the complex conjugate of the denominator. So let's divide these. All right, I need to multiply the numerator and denominator by the conjugate of the denominator. So the denominator is 1 plus I. So we're going to multiply by 1 minus I. It's the same numbers, different sign in the middle. So then we multiply. 2 times 1, 2 times negative I. Negative 7i times 1. Negative 7i times I is be plus 7i squared. The bottom will be 1 times 1. 1 times negative I. 1 times I. And negative I squared. Alright, so on the top, I can combine the i's to make negative 9i. And I squared is negative 1. On the bottom, I can combine the i's, which cancel out, and I squared is negative 1. On the top, I can combine the 2 and the negative 7 to give me negative 5. And on the bottom, 1 minus a negative, same thing as a plus, so it's 2. Now usually we split this, so the form is a plus bi, so we have 2 separate parts. So I can split this into 2 fractions. Negative 5 over 2 minus 9 over 2 I. If you have one denominator, you can split it. Let's try again. Why don't you pause the video and try this one? The conjugate at the bottom, it would be 2 plus I. So I'll multiply the top and bottom by that. The top we could distribute to get 4i and 2i squared. The bottom will have 2 times 2, 2 times I, negative I times 2, and negative I squared. All right, remember I squared is a negative 1. The bottom, I can combine those, which cancel out. And I squared is negative 1. Usually we'll put the numbers in front, so we'll put that part first, so negative 2 plus 4i. And on the bottom, the minus the negative is same as plus, so it's over 5. And then we can split it into the two fractions. Negative 2 over 5 plus 4 over 5i.